So let's talk about a concept in data center fabrics or data center design that's called service chain or service graphs. What that basically means is very straightforward stuff, is that you don't want to put any of your services, especially a service like Firewall or any other services like load balancing or anything inline. So when we say inline, you don't want your firewall to be connected here as the first hop for the traffic to go to. So the default gateway is not the firewall, it's the router. But if I don't put a firewall as my default gateway, which is, sometimes in some use cases it would make sense, but it gives you less flexibility. All the traffic then has to go to the default gateway, and then you're going to have to configure, let's just say if this is the firewall, right? And then all the traffic would hit this guy, the firewall, and all kinds of traffic would need policies on this firewall. So that's a lot of work. What typically is much more flexible is that you create a standard topology that's good for your routing and packet forwarding, like this one. And then you create, and so therefore the default gateway for such topologies, and especially in data centers, is going to be your exit router. This exit router will route everything to your applications or services or whatever. But then certain traffic or certain traffic users that are sitting on this segment or other segment that needs to be redirected to the service or a firewall, what you can do is use policy routing in that case to match the source of these traffics or source of these users and then redirect them to a firewall sitting on a different segment. So the default gateway would still be the router, but on the interface that's taking in that traffic would redirect to the firewall. And in this case, the firewall will permit or deny the traffic going from, let's just say, zone V1 to zone V4. And if you want, in our case, we are permitting everything from zone V1 to zone V4, but we're denying everything from zone V4 to zone V1. So we have a policy route on this interface, a policy route on this interface, and therefore the traffic in both direction would now ensure that the traffic gets redirected to the firewall here and match the policies before they're permitted. So the policy routing video is already up. You can take a look at that. But let's take a look at the configuration or the traffic pattern right here. So if this is V1, we go to V1 and we run a trace route, and you'll see that it's taking this path from 1201, setting from a 1201 to default gateway 1202 right here, and then it hits 2310, which is this guy, and then it goes to 2320, which is this segment, and then it hits 444, which is a loopback right here. So this is a trace route that we did, and it's going like this in a graph. This is a service chain or a graph, even though the default gateway is pointing to 12002. So what does that mean? That means that if I do show IP route, I would see that my default gateway, default route right here, and my default gateway is pointing to 12002. And obviously 12002 sits right here, and my firewall is sitting on 2310. and 2320. So the way to achieve that is obviously through policy routing. That's the key right here. And there's a video on that. I'll show you the configuration for the policy routes. But the firewall in our case is really permitting the traffic from zone 1 to zone 4, but not the other way. It's rejecting everything going this way. So let's look at the firewall, which is v3. Here's the rule. It basically is saying that from v4 to v1 you reject, and you have to make sure that everything is permitted from v1 to v4 with these options here. And then to make sure that your ICMP or pings and traceroute works, you have to permit action except for these two. Make sure UDP is for traceroute and ICMP for pings. That way you will achieve the traceroute as we did here. Now if we were to try to run a ping to 1201, it's clearly saying it's rejected. That basically means the firewall is rejecting the message. So if I were to trace this, I think it's going to do the same. Trace 12001. It's going to give you a bunch of stars. And so essentially it will go all the way to 2023. It's coming all the way till here, and it's not able to reach 12001. That's how the reject option is telling you. So ping is obviously not going there. SSH is obviously not going to be allowed either because I'm not permitted. It's clearly saying connection refused. If I go do SSH from this guy, it's gonna, there you go. So the traffic is allowed one way, and the key for that is obviously again the state policy established and also the related action except. But I have a video on that too for firewalls. But the concept that I'm trying to demonstrate here is again service chain. The service change. The key thing to remember is that you don't want to build topologies that has inline services. You can put the services, anywhere except for the inline, and then route the traffic to that service. That gives you a lot more flexibility to get the services for specific users and not all the users. You can always do all the users, but that creates a nightmare of creating all those policies to allow some users and not allow other users and so on and so forth. Hope this helps you understand the service chain, service graph concept.